Hi, welcome back to McClutchy Maths. My name is Natalie McClutchy and today we are continuing our index laws series by looking at index law 2, which is all about dividing terms with the same base. We're going to do a very quick recap of indices at the beginning of this video, then we're going to unpack the law, do some worked examples and have a quick chat about what's coming up next. Let's not waste any time and get right into it. So let's quickly think about what we know already about index laws. You would recall that index laws always apply to terms with powers that have the same base. And this is how we set it up. So we're using the letter A to represent a letter or a number. It's what's called our base, and it's written the same size you would write normal numbers. We've also got a power. It sits up to the right-hand side, and it's up in small writing, just a little bit higher, and it's our power. And it tells us how many times the base has been multiplied by itself. Now you would recall from our previous video that index law 1 is all about multiplying terms with the same base. And in that particular case, we add our powers. So this was our law for index law 1. We've got the same base, which is the letter A, and we've got different powers. So we've got a multiplication in between those two same bases, and that means instead of multiplying the powers, we add the powers. And in that last video, we talked about why that law works. Well, today we're talking about index law 2, and in this case, when we've got two or more terms with the same base, that base being the letter A, and when these are divided, instead of adding those powers, we subtract them. So that's something important to remember. So plus and times go together with index laws, and divide and take away go together with index law 2. Okay, you'd also remember, perhaps from primary school, that division can be written as a fraction as well. So let's go back to our previous law again on the previous page. We've got the divided by symbol here, and this term is divided by that term, so we take these powers and subtract them. But we could rewrite this now as a fraction, and I've used different letters up the top this time, and we've got that first term, same basis again, is the letter A. Instead of the divided by symbol in between, we've got this fraction term. It also means divided by. And in that case there, we do a subtraction of the powers too. Okay, we're going to kick off with a few worked examples now. We'll get straight into it. So for this one here, we're going to use some real numbers, 3 to the power of 8 divided by 3 to the power of 3. Now you might be tempted to get the calculator out and type in 3 and multiply itself by itself 8 times, and then divide that by 3 to the power of 3. Well, you're not actually being asked to do that when we work with index laws. That's called calculate or evaluate. In this case, we're simplifying. So what we're going to do is we're going to write down our law first, and that's going to be our reference point. And then we're going to pop our actual question underneath the index law so we can match the law to the question that we've got, so we can basically match what's going on. Now you can see over here it's telling us that when we've got this divided by same base, in this case our base is 3, we subtract those powers. So we're going to do 8 take away 3. Now this is a step of working a lot of students skip. I would say if you're in 7, 8 or 9 grades, it'd be a good idea to start showing that working. As you get a little bit older, you can do a lot of that in your head. But when you've got big complicated things to do, this is not so complicated, but it does get complicated later on. Showing that working step there is an important step. It might even actually be worth marks at your school. Okay, well we know 8 take away 3 is 5, so our answer is 3 to the power of 5. Now, you might be wondering, where did this rule come from? In our first video, we explained where the rules come from, so let's explain here why this rule works too. Well, you would recall that 3 to the power of 8 could also be written as a fraction. We did talk about that a few moments ago. And this is easier to explain when you see it in fraction form. Let's expand that 3 to the power of 8 out, as well as 3 to the power of 3. And you can check that I've got the right number of 3's there. That's what it looks like when it's expanded out. You can see why writing 3 to the power of 8 is so much quicker and easier. Now we know that anything divided by itself is equal to 1. This is one of those ones that a lot of students get confused. They think that 100 divided by 100 is 0, or 10 divided by 10 is 0. It's not. Anything divided by itself is always the number 1. So if anything is the number 1, we do what's something that's called cancelling it out. Because, for example, 3 divided by 3 makes 1. Anything multiplied by 1 is just that thing. So 10 times 1 is just 10. 1,000 times 1 is just 1,000. So all of these 3's times by 1 is going to be all of those 3. So we're cancelling out the 3 divided by 3 because it's equal to 1. We've got another 3 divided by 3 there. We're going to cancel that. Another 3 divided by 3 there. Now you might be wondering, well, what is left on that denominator now? If I've cancelled out all of those and they've gone away, what's left under here? Well, it's just the number 1 because it's now multiplied just by 1. So now I've got 1, 2, 3, 4, 5 3's left. That's 3 to the power of 5. You'll notice that's our answer over here. That's what we were working towards when we used our shortcut rule, because we certainly don't want to have to expand everything out and cancel everything every time we do index laws. That's why we have a nice little shortcut rule. Okay, so now you know how the rule works. We're going to apply that rule with a few other worked examples. Let's move on from real numbers now to some algebra. A to the power of 12 divided by A to the power of 4. So once again, we're going to write our rule. It's a good idea to write your rule every time, just so that you get in the habit of learning that rule off by heart. After a while, it'll just become second nature to you. You won't have to write it anymore. It'll be ingrained in your memory. Okay, let's match up our question underneath so that it's all matching. And we know our rule is that we're going to subtract those powers. 12 take away 4 is 8. And we've got A to the power of 8 is our answer. Now, if you're not thinking particularly savvy, it's very easy to get confused and think, well, if I've got a divider by here, then I do 12 divided by 4, and the answer would be A to the power of 3. We've just seen why that doesn't work with the cancelling strategy. So you've just got to remember it's all about takeaway, and that's where exams will try and trick you up. They'll put something in there that's nicely divisible so that you'll automatically think, oh, it's going to be 3. It's not. It's 12 take away 4 makes 8. Let's try something a little bit more complicated. This one's in fraction form. We've also got 2 different bases here. We've got m's, we've got n's. So what we want to do is focus on one letter at a time. So we're going to focus firstly on the m's. So if we look at our fraction, top to bottom, we're going to have a 5 take away the 3 following our rule. And then our n's, 7 take away 2. And then it's a simple case of simplifying that. We get m to the power of 2. And 7 take away 2 makes 5, so we've got n to the power of 5. Now you might be wondering why they now still stuck together. It's because they've got a multiplying in between those. So we smush things together when we times them. Okay, next example, we're starting to get a little bit more complicated this time. We've still got 2 bases, a j and a k. So once again, we're going to treat those separately. We've also got these whole numbers out the front. Now these whole numbers don't have powers next to them. You'll notice that. So we actually just treat them like a fraction that's multiplied by the rest of the fraction. So we can actually do the division. It's 8 divided by 2. So we can simplify that. 8 divided by 2 is actually just 4. So the 4 will sit on the top because it'll be 4 over 1. Because if we divide the top and the bottom by 2, we get 4 over 1. But we just don't need to write the 1. Okay, so we write our rule again. So I'm going to simplify that 8 divided by 2 to simply a 4. So normal division rules apply to normal numbers that don't have powers. And then we're going to deal with the power here. So I've got 10 take away 5 and I've got 4 take away 6. So I've put this question in there deliberately because you can end up with negative powers. So let's do that. 10 take away 5 makes 5 and 4 take away 6 makes negative 2. Now in a future video we're going to talk about how to actually present our answer if we've got a negative power. But for now, we'll just leave it in this form with a negative power. So just be aware. Just follow your normal rules for adding and subtracting integers. You can also have powers that are decimal numbers and things like that as well. So just follow your normal rule for adding and subtracting whole numbers and fractions, etc. Well, that's all we have time for in this video. We are going to do more complex questions in upcoming videos and also unpack all of the other laws. So if you want to know when those videos are available, you're going to have to hit that notifications button and like and subscribe to the channel. And you can also engage with us further. We always announce when new videos are available on Facebook and Instagram. And as I said before, don't forget to like and subscribe. We love to see you here at the channel. You can also let us know in the comments if something you saw today was helpful. And also any questions that you have, best not to put those in the comments. You can direct those straight to us at mcclutchymaths@yahoo.com. Always pretty quick to reply to your emails. Thank you so much for your time today. You've been watching McClutchy Maths. Have a wonderful day.